Intro to Swift programming. Obviously, everything we're talking about is based on the beta version of Swift that was released a few weeks ago. The one big caveat that Apple uh, announced to everyone about this is the language syntax is subject to change. So they've been working on it for, they say, about 4 years. It's pretty solid, but I know there are a number of rough edges still. Um, they did commit, though, that any code that we build at this point um, would be binary compatible with the Swift runtime. So just just take that with a grain of salt, basically. Um, so I work for a company called Focal Shift. So does my business partner. His name's Terry Tucker, and basically we do contract iOS development, and we're pretty excited about Swift at this point. Trying to learn about it just as quickly as everyone else is. Um, okay, so introducing Swift. Uh, when I sent out the invitation for this session, I asked a question in a little poll of how many people were sort of new to Objective C or sort of new to iOS development, and quite a few people seemed to indicate that they were fairly new to it. Uh, I'm assuming that this is in part because Apple has announced fairly clearly that Swift is designed to be both a sort of a professional grade language for building iOS apps and Mac OS apps, but it's also intended to be very approachable for newcomers that are interested in building iOS apps. Whereas in the past, Objective-C was perhaps um, a little bit more of a challenge, especially with things like pointers and all the memory management stuff that had to take place.
So I went into my queue and typed in the username and password so that it
Um,
would go that way. But then I had to go back and remember if I reset the password.
the people that
So I
just
have a really
joined,
big list of
if
ones
they
that
could mute their microphones, that would be appreciated.
but it's a pretty
Um,
big list.
okay, so
You just want it by UAR number, right?
so Swift is
Okay.
intended to be a high level
Just
language.
UAR number and then Excel file. Okay, yeah. Perfect.
Sorry about that. I wish there was a way I could mute everybody, but there doesn't seem to be a way I can do that easily from this end. If you just recently joined the call, could you please mute your microphone? Okay, so one of the big things that Apple has has been working on with Swift is trying to make it a lot safer, and you're going to see this emphasized a lot in their documentation and in the constructs of the language. Basically, they are looking at all of the kinds of errors that developers make when they're using Objective-C. A lot of errors are around how they manage pointers or how they handle the mutability of variables, and they're trying to make the Swift language uh, safer by making it harder for you to make mistakes. So basically, the compiler is going to start enforcing more rules on how you write your program, such that you can't make the kind of mistakes that previously were made by a lot of developers. Um, they say it's a clean state, but it's backed by the maturity of Cocoa and Cocoa Touch. We'll get into this a little bit more as we go through the hour here. But basically, it's a full-blown language ready to go, ready to build iOS apps today. Um, they also say it's friendly for new programmers. I think this is possibly a little bit of marketing speak. Uh, Understand that it is a very powerful language, and there are a lot of constructs in the language that will take some work to understand and utilize well. Um, at the same time, though, it's also a very approachable language. You can definitely jump right into these things they have called playgrounds and start experimenting with the language um, without needing to know everything about it. So I think it will be good for teaching. It will be good for beginners building iOS or Mac OS apps. But there is still, like, I guess what I'm saying is don't think of it as a toy language. It's definitely industrial language. These are some of the things that make it an industrial language. So You might have heard these terms in reference to some other languages. A lot of these things are not present in Objective-C, but they are present in various functional languages or some other high-level language. Like some of these things are borrowed from Ruby on Rails. Some of these things are borrowed from Python or from things like F# or Clojure or Scala. Uh, so the big ones that obviously that Apple highlighted during their presentation were Clojure's generics, type inference, um, multiple return types, and namespaces. So all of these are things that people doing Objective-C development for a while have been asking for, and now we have them. So their big push, like I said earlier, safe, modern, and powerful. If you watch any of their presentations, they will call out on all of the different slides as they're presenting information about Swift, one of these three icons, either indicating they're talking about something that improves safety, or that is a modern language construct, or that is a very powerful sort of feature of the language. Okay, how many people here heard about Swift and then immediately wondered, is Objective-C dead? I'm guessing probably quite a few. I know I thought that when I saw the stuff being announced. So I think there's probably two camps on this. There probably are some people who are crossing their fingers and hoping that Objective-C is dead and that this book in this trash bin here represents the future of Objective-C. The reality, though, is pretty far from that. To be an effective iOS or Mac OS developer these days, you are still going to come in contact with quite a bit of Objective-C code, in large part because most of the frameworks that you rely upon when building an application are all built in Objective-C. There are also features of Swift that are present exclusively to help with the interoperation between Swift and Objective-C. So even just to understand those language constructs in Swift, you probably have to understand some degree of Objective-C to be able to know why it is certain things are the way they are in Swift. So the answer is basically no. Objective-C is not dead. Apple has not deprecated it. I think people are still going to be building and shipping iOS and macOS apps that are written 100% in Objective-C. Some people will build apps written 100% in Swift. Of course, those will still be based on top of the frameworks that are built in Objective-C by Apple. And then a lot of people will take existing apps that are written in Objective-C and they will slowly migrate those apps over to Swift by adding new classes, or maybe the new functionality in the app will be done. I imagine there won't be a lot of people that take an existing iOS app that's Objective-C based and devote the time to actually rewrite the entire app in Swift. That's not something I would imagine a lot of people taking on. So as a developer, then the big question you have to ask yourself is, what kind of developer do you want to be? Do you want to be the totally cool, hip Swift guy here, or do you want to be the stodgy old Objective-C guy? Again, I imagine people are hoping that they can sort of just be the Swift programmer. The reality, though, is if you're going to get into this stuff, you're pretty much going to be an Apple developer. You're going to be dealing with a certain amount of Objective-C, a certain amount of Swift, and sort of have to learn about all the different aspects of the ecosystem. Okay, so to get started with Swift, the thing you need on your machine is the Xcode 6 beta. The Xcode 6 beta is available from download on Apple's site. You can't actually download it, though, unless you're a paid member of the developer program. Eventually, I imagine it'll be available to everyone, but at the moment it's not. So you need that, and that'll install and run just fine on Mavericks. Or you could install it on the new beta OS Yosemite, either one. I'm running it on Mavericks. Then you probably want to grab a couple of books that Apple has made available on the iBookstore. It's the only place they've made them available. There's no print version of them that I'm aware of. You can't get them from Amazon or anywhere else. Um, but you can grab them and read them on your iPad, I guess. Um, so you get those two things: get the books, get Xcode 6 beta, and then the place I would start is I would start by jumping in and using these things called playgrounds, which we'll show you what those are in a moment here. Um, there are other ways you can also build apps from the command line, or you could just start building an Xcode project. But I think probably that's jumping the gun. Playgrounds is a good starting place. The two books, these are the titles. Excuse me. The Swift programming language, that is the book that they released on day one when they announced Swift. It's kind of the Swift equivalent of the Pickaxe book for Ruby, or maybe the K&R book for C. It's the go-to guide. It has both sort of an introductory section at the beginning, and then it has a reference manual in the back of it. And it's like 500 or so pages long, so it's not a small, quick read kind of a thing. The second book that they released more recently, I think they released it just this last week, is Using Swift with Cocoa and Objective-C. This book really talks about how to interoperate between the two languages and how to do things like slowly evolve your Objective-C project to start using more and more Swift. Like I said, you can install it on Mavericks. It can coexist with Xcode 5 just fine. So it'll basically be a separate .app sitting in your applications folder. In order to use the Swift command line tools, assuming you want to use them, you would need to run this thing called Xcode select from a terminal window in order to switch yourself from the production version of Xcode to the beta version. And I will show you how to do that in a few minutes here. The one caveat I would give is that when you have both versions of Xcode installed on your machine, if you're in the habit of going to Finder and just double clicking on a project file or a workspace file to open it up, there's a good possibility that it will open them up in Xcode 6 beta instead of Xcode 5, even though they're maybe for one of your existing projects. So be careful about that. Maybe do the right click and open with thing to select the correct version of Xcode. Okay, so when you launch Xcode 6, you'll be greeted with a welcome screen that looks like this, similar to the one from Xcode 5. But there is a new thing here. There's this Get Started with Playground. So if you click on this guy here, what will happen is it will not create a new project for you. Instead, it will create a single file which has the .playground extension. And this file contains like a scratch pad, basically, that looks kind of like this. Basically, it'll start over here in this area of the playground. You'll be able to write Swift code, and it's interpreting or evaluating this code in real time. As you're typing code over here, it's going to be showing you the results of evaluating your code over in this other area on the screen. There's some other interesting features that I'll demonstrate as we use it, but the basic model is a playground is one big file here where you can type out some Swift code and do some experiments, and you'll see the results as you're running it. It's pretty handy. An alternative way to play with Swift is to do it from the command line. If you're someone who loves Emacs or loves VI and you want to get in there and just write some little sample programs using Swift, you can certainly do that. A Swift file is a text file that ends in the .swift extension. And there's a command line tool just called Swift, which will let you evaluate these text files. In order to do that, you have to run this Xcode select command here. Basically, what this command will do is it will make it so that when you then later run this xcrun command, it will be able to find the Swift binary. If you don't run this Xcode select command, when you try to run xcrun Swift, it'll tell you Swift is not found because xcrun will be looking in the Xcode 5.1 package in order to try and find executables, and there's no Swift compiler in there. A term that Apple uses when they talk about this command line tool is REPL, which means read, evaluate, print loop. And basically what they're referring to is they're referring to this continuous loop that the Swift interpreter or command line shell goes through as you're typing in lines of Swift code. It's reading them, evaluating them, printing out for you whatever the result or possibly a compiler error is, and then it's going back and waiting, prompting you for another line of code. When you're running the Swift REPL, if you want to exit, you would use the command :exit, and that'll exit you back out to the command shell. This is what that would look like. So here is maybe a first look at the Swift language. So I ran that sudo Xcode select command to get myself into the beta version. And then I run xcrun swift, and that launches the Swift REPL. And from inside the Swift REPL, you can just start typing lines of Swift code. And as you go, you can see this second line here, var string hello playground. It just responds by printing out what the variable was that was defined and what its value was. And then in this case, I just exited. Okay, so the four things that I'm going to actually go through demos on in the playgrounds are literals, types, operators, and functions. And then in a future session, I'll include additional features of the language. All right, so. All right, let's see here. Okay, so all of these files that I have here that I'm going to go through, they are all available, and there's a link in the in the sidebar there of go to training. There's a link to a Git repo where you can grab all these things later if you want to play around with them as well. So I'm going to open up this workspace here. Okay, now in the workspace, I've got a number of separate playground files. When you initially launch Xcode, I think someone joined the call recently, and if they could, please mute their microphone. I'm hearing some feedback.
Yeah, can you hear me?
Yeah, I can, yeah. But I can also hear myself.
Oh, so I should mute the microphone?
Yeah, mute the microphone, please. Yeah, thank you. Okay, so when you first launch Xcode, like I said earlier during the slides, you'll be greeted with this welcome screen that looks like that. And if you just say get started with a playground, it's going to ask you to create a playground and place it somewhere on your machine. Basically, I did that to create my first playground file. And then after that, let's see if we can make this a little bit bigger here. I think that's a little better. So after I created the first one, then I actually went into Xcode and created a workspace file and started adding additional playground files to it just to help me keep them all organized here. But that's not required. It's just that's what you're going to be seeing on the sidebar here. Okay, so the first thing here is before we can really write any programs with Swift, we really kind of just need to understand the scope of what kind of literals are possible in the language. So if you notice here, every one of these lines, like line 6 here, the stuff that's over on the other side here, that's the actual result of having evaluated that line. And there's also a output area here where you can see information about what you're looking at. I'm going to close that up again for a moment. So you can see integers, base 10, base 2, base 16, base 8, right? So all of those are different ways you can write an integer in Swift, not unlike how you would do it in C or C++. You can put leading zeros on a value and they're just ignored, right? So both of those are the same for 100. You can also put underscores in to just like break up the value of a literal to make it easier for you to look at it. They don't actually have any meaning once this literal is interpreted. So you can see both of those are the same value. Floating point values, you can write them in decimal notation or scientific notation. Sort of an odd thing I haven't seen before is you can also write them in floating point if you want. I'm not really sure what the use of that is, but you can do it. So this is an example here where it's 15 times 2 to the minus 2, and there's your answer. Kind of a, I don't know what it would be used for. Maybe someone else knows. Okay, so in addition to integers and floating point numbers, you also have strings and string literals. A simple one is just something in double quotes. If you're familiar with Objective-C, you remember that an Objective-C string always had an @ sign in front of it. That's not something that's necessary in Swift at all. So it's just the quotes, nothing else. You can embed or escape certain special characters. So here's an example of creating a string that has quotes inside of it. So you can see that right in there, there's the quotes. And you can do this quick look thing if you want to look at the whole string there. Another thing you can do is something that's a little bit unique. You can basically do this expansion of values inside of a string. So here we are, we're creating a string literal that says 2 plus 2 equals, and then we do a backslash and an opening quote, or sorry, an opening paren. And what this does is this starts a expression in Swift. So this is not going to be part of the string. What's going to be part of the string is the result of having evaluated this expression. So here you can see it becomes 2 plus 2 equals 4. And this is a very convenient way, we'll see later on, to insert values into a string. Basically, think of this as sort of the equivalent of doing append with format, or like an sprintf if you're familiar with C or C++, to format up a string. Okay, so two additional types that we've got that we can specify as literals are arrays and dictionaries. An array, all of the values in the array, when it's a literal here, are of the same type. So we can create an array of all strings, or we can create an array of all doubles, or we can create an array that looks like mixed types, but each of these will actually get turned into what's called an any object type. So technically all of those things in that array are going to end up being of the same type. Okay, so arrays are pretty straightforward. Dictionaries look similar to an array, except we have both a key followed by a colon and then a value. But they are still defined within square brackets. And you can see here is, here is our dictionary, right? 3 things. There's the key, which is dog. It has 4, which is intended to mean the number of legs in this case. A bird, 2 legs, a snake, no legs. Okay, so those are some basic examples of literals. Let's move on to types now. All right, the way we will declare a type in Swift is by using either a keyword called let, so something like let, or var. The distinction between these two things that we will see is let is an immutable value, so it cannot change. And a var is a variable that is a mutable value, and it can change. So that means if I try here and I say like something x equals 5, that's going to be an error. If I say y equals 5, that's going to be permitted. So on this line here, you can see Canada assigned to let value x. Okay, so that's not permitted in the language. So what we're looking at right now with types is we're going to basically be looking at what all of these values are here, right? So here x is an integer. We're going to just go down a list here and look at the different types that are available to us. So we have two broad classes of types. We have name types, and then we have compound types. Name types are things where you can give them a name, and you can then refer to them later on. Typical things would be a class, a structure, or an enumeration. Some examples here, we've got a variable called 1. Its type is double. So we have doubles and we also have float. And then we've got another one here, which is a string. Then we've got an enumeration called direction. So those are some pretty basic things. Compound types are the most typical example of a compound type is something called a tuple. Functions are also a compound type, but we'll get to that later on. So a tuple is a multi-valued variable. So here is an example of a tuple that has two doubles being stored in it. So this is not a struct and it is not a class. It is just a variable that happens to store multiple values. And so here you can see that it's being assigned to these two floating point values. And then this is actually an example of another compound type, which is the actual function here. Here's three tuples. One thing you'll see, the first two tuples are considered to be anonymous. So I've got this tuple here, and I don't know how to refer to the first value in it or the second value in it. Same thing with the second one here. I've got a first value as a string, second value as a double, but I can't refer to them. This third tuple here, I actually can declare a tuple and provide a name for each of the two values. And so this is starting to look a little bit more like a structure because I actually have names for the variables, but it's still only a tuple. Let's see, what else have we got? Function. So if I want to create a function, a very simple example, I'm creating a function called display message. I'm going to return a value of type void. Now, the first time you see this, this is probably going to seem backwards to you. People are usually used to something like void, something like that, right? Where you're reading the name of something, you're saying, well, this is the return type, and then this is the name of it, and then possibly there are some parameters after it. In Swift, it's exactly the opposite of that. It's the keyword func for a function, and then whatever you want the name of it to be, and then any parameters if there will be any. And then there's this arrow operator, and then there is the return value or values for the function. Calling a function looks the same as it does in other languages, display message, that calls it. And in this case, if we go look over here at our output window, you'll see that when I call display message here, that causes the actual console output to actually print out hello world, which is being printed right there in that. Turn that off again. Okay, let's see, array types. We saw what an array literal looked like in the previous playground. So there's a literal for an array, and here's how we would assign it to a let variable called sum array. So I can declare some array of type string array and assign those values to it. This syntax right here is actually just a shorthand in Swift for typing out the word array and then an angle bracket and the actual type of the elements in the array. So this type here is the same as that type there. And other than that, these are basically the same thing. These are both just basic arrays. If I want to access elements of the array, I can access either an individual element by providing the index to it inside square brackets, or I can access a range of values inside of an array. So in this case, I'm accessing element number 1 and element number 2, because this is an example of a range that is not inclusive of the last element. So that's the same thing as if I looked at sub 1 and sub 2, right? It's those two guys right there are what are being returned when I ask to look at a range within the array. Arrays are smart if I try and access something that is, come on, that is outside of the array. I'm waiting. So sometimes this environment doesn't spit out the error it should. Still definitely a beta tool. This should return an error to me right here, but I don't know why it's not at the moment. Let's see if this one. Yeah, I'm not sure what the deal is there. So both of those are errors. I can't access element 3 because they're only 0, 1, and 2. And I can't access -1 because that's also out of range. Interesting that I'm not seeing the error. Oh, I am not seeing the error because I don't have it turned on. There we go. Okay, so here's my errors about. Basically, it tried to evaluate these lines and negative array index, or I believe this one as well, then array index is out of range. Okay, so one thing to know about the playgrounds is if you do get an error, like if you noticed what happened there, I had 2 errors, and actually it stops evaluating when it gets to the first error. All of the rest of the code in the playground is not evaluated. It just bails out after the first one. So you pretty much have to just go down the line and fix errors one at a time. There's no way to have it like compile all the code and give you the list of all of the errors here, at least not in the playground. If I wanted to create an empty array, I can do like this, just open and close brackets on both sides of the assignment here with no values. If I want to create a multi-dimensional array, I can define the number of dimensions here, so it's a 3-dimensional array. And then I just start nesting the square brackets for each of the levels of the array. So you can see this multi-level array was created, and then array 3D sub 0 is everything that's in the first element at the outermost level. So that's my two inner arrays. And then I can get to a specific array, or then I can get to a specific element of an array. Optional types. So there's a history behind how Objective-C treats pointers. Almost every method that's part of an Objective-C framework will deal with pointers to other objects. And those pointers can either contain a value or they can contain nil, meaning they're not currently pointing to any valid object. In Swift, the way that concept of something that is currently not defined is modeled is through something called an optional. And when you declare an optional, you do not have to assign a value to it immediately. So here we are, I've declared an optional integer, and the way Swift knows that it's optional, or the way you indicate it's optional, is by putting this question mark on the end of the type. So I can say optional integer int, and you can see over here that the value of it is currently nil. If I want to, then I can actually assign a value to it later on, and now it has a value, right? Alternative syntax, that is really just a shorthand for the word optional, and then in angle brackets, the actual type of the optional. And when we look at how to interact between Objective-C frameworks and Swift, we'll find that we end up using this optional construct quite a lot. Basically, all of the return types that are coming out of Objective-C, they will all be declared as optionals. Last thing here is this notion of type inference. Basically, if you notice, a lot of the things all the way along back up here that I declared, I always declared the data types of things, right? Like these two doubles here, or this string array. It turns out in Swift, quite frequently, you don't have to specify the type at all. And it's not that that means the language has some kind of a type like maybe Perl has, where it can store values of any different base type it wants. It's actually that it's inferring at compile time what the type is. So these two lines are the exact same thing. The first line is I'm explicitly declaring an integer. It's explicit because I said what type I want it to be, and then I'm assigning it the value of 10. Excuse me. This next line here, an inferred integer, I'm declaring the name of the variable, but I am not specifying the type. Instead, the compiler is going to look at this value right here, and it's going to know the type of that literal, and based on that type, it's going to assign the type int to the value. So I can do the same thing with a string. And those are the same thing. There's no difference between those. The only difference being you didn't have to type as much. So I think a lot of people really like this concept because it makes the language a lot more concise. Anyway, you get the basic idea. All right, let's move on to operators. Sorry, I just saw the question someone asked. Can you set up optional lets? That's a really good question. I don't know the answer to that, but I suspect the answer is yes. Let's just find out. So I could imagine that you could do something like that, where that function returned an optional, right? So it's going to be a constant, and you're only going to assign it one time, but it's going to be assigned based on some function being evaluated, which may or may not actually have a value. So I think that will work, but not positive, not 100% positive. I'll have to play with that some more. Okay, operators. For the most part, operators in Swift are the same as Objective-C or maybe Python or Ruby. They're kind of all the same. These are the symbols we've got available to us. You can see, typical things: plus, minus, equal, not, multiply, divide, modulo. So if I declare a couple variables, A and B here, typical binary operators, A plus B obviously does addition, A plus B like that does addition. The thing to point out, though, is these two that I've got commented out here. These are not valid. So if I do that, bring this guy back up. Okay, this is a parsing error. Oops. Let's see. So it says consecutive statements on line must be separated by semicolon. Now, the deal here is it is not able to see that single space followed by a plus as being a binary operator to do addition here. Either you need no spaces or you need two spaces, one on each side of the operator. Sitting like that, it thinks you're trying to write A as one thing, followed then by another statement, which is plus B, which is kind of nonsense. Doesn't really make any sense at all. So the same thing is true, whether the space is after or before the operator. These are just both syntax errors, effectively. So not much to see here, just simple basic math on each of these. The last one here, 3 divided by 2, notice it got truncated to 1. It dropped the 0.5 off the end of it. It didn't round it up or anything like that, doing the integer division. Dividing on doubles gives you what you would expect. A double and an int gets type inferred to being double on either side, numerator or denominator. If you want to deal with a remainder, here we've got 2 constant values, actually 3, P, Q, and R. And you can see that they were inferred to be integers. Therefore, the remainder is also an integer. Same thing down here, except for but with floating point values. So the remainder in this case is a float, which this is somewhat unusual, at least if you're coming from a C or C++ background. You can't typically do modulo arithmetic on a float in C or C++. Okay, let's see, a tuple. We talked about a tuple a little bit back when we were showing you literals. Here's how I would declare an actual tuple as a immutable let variable. So I'm going to define a tuple that has 2 values, fx and fy, and I'm going to assign it to these 2 values here. I can then refer to the individual elements of that tuple just by name. So fx or fy, and that works fine. So we have unary operators, same as C or C++, prefixed or postfixed, addition or subtraction. Comparison operators, same as other languages. To refer to the whole tuple, you have to give it a name. So we could give this tuple a name like foo. I think it's foo colon. I don't think that's right. I don't remember the exact syntax actually, but basically you can give it a name right here. This example, I think maybe I need the type in here now. I better not try right now. But basically, yeah, you can give it a name. Let's see, so comparison operators, and then we've got range operators. So I mentioned earlier when we were looking at something on the previous set about the open range. So here we have an open range, which was the 1.5, which means it includes everything up to 4. And you have a closed range. If you add the extra dot, then it'll include the 5 at the end. So you can see these are 2 examples here of looking at the console output over here of it actually having printed out 5 values for the first one and then 4 values for the second one. Logical operators, nothing out of the ordinary here. We've got, in this case, I created 2 values, a length and then a flag. The flag got assigned the value of false. In fact, I could probably, I could have just taken that stuff right there out and it would have inferred the Boolean value for it. Checking the values results in some Boolean bit of logic. And I can combine multiple Booleans together with ands or ors, and it evaluates the way you would expect. On to functions. Okay, so the simplest form of a function is a function that takes no arguments and returns nothing. And so that's what this example here is, assign a message. I have a global variable to this file here. It's an optional string. It doesn't have a value at this point, right? It's nil. Then I have a function here that assigns the message. So inside the function here, I'm assigning to the variable message. And you can see that it doesn't return anything at all. So I call the method, call the function, and what I get back is hello from a function. Now, when you see this value here that says sum, go up here to this guy. Oops. Sum is an indication of what the value is inside of an optional. So it's just a keyword that you're going to see over and over in here. Okay, so we called the method, and then I actually just printed out the value of message here so you can see what it is outside of the function. Simple function that returns a string. So basically it's the same method, same function as before, except for now we return something of type string. And we call the method, and you can see that it evaluated to the string on the outside here. Function that adds some numbers together, passing parameters in. So each parameter, you have to declare the type of a parameter. It cannot be inferred from some call site. So the compiler isn't going to look at this line and say, oh, you're passing in 2 integers, therefore I know A and B are integers. It doesn't do that. You have to, when you write the function, you have to express what you want the types to be. So we've got a function here that takes in 2 integers and returns back another integer, and it's just doing the addition there. So we call the method with 10 and 10, and we get back 20. And so here we've got a function parameter that we want to try and change inside the function. I'm going to uncomment this, and you'll see the error that we get. So what we're trying to do is we're trying to take this value that's passed in, this integer, and locally we want to use it, let's say, and so we want to add 10 to it. And when we try to do that, you can see that it says error cannot assign to a let value. So the implication here is that all of these parameters that are coming into a function, they are all let parameters. They are not var parameters, meaning you cannot change them. They are immutable. So this is an error. Can you override function signatures with the same name but different data types? Yes, you can. So you can do function overloading. Yep. Yeah, you could do both of those that you just put in that example there, definitely. Okay, so that didn't work for us. If we want to do something like that where we want to refer to a variable internally, we can actually express the function in a way that lets us do that, but we have to use this var keyword. So the let we didn't have to specify, but var we do. So here at this point we can now actually change the value. Now this doesn't maybe do exactly what you're imagining it would do though. So notice here we're starting out with a v equal to the value of 10. We're going to call this change value locally function. So we're passing in 10, and inside here we're adding 10 to it. So clearly the value becomes 20. But then when we return outside of that function and we come down here after the call and we check to see what v is, notice it's still 10. Okay, so this is not causing us to pass by reference. We are still passing by value, and the value comes into the function. It's just that now we're allowed to use it locally inside the function. If we actually wanted to pass by reference, then we have to use a different keyword instead of var. We need to use the keyword in-out. And so here, this function change value by reference. We're passing the value in. We're adding 10 to it. And so I declare a value with a variable with 10. I pass it in. And notice that the syntax for passing it in now includes this @ symbol to indicate that there is a someone's asking a question if there's going to be a follow-on session. So I'm going to try and wrap this up in just a few minutes here. And then, yes, there probably will be another one next week. I'm going to send out another announcement via the meetup group probably later today. Okay, so this @ symbol is what's used to let us pass in the variable such that we can actually modify it by reference. And when we're done with the function, we're still able to use it here. Okay, moving on. We can also have optional types. Oh, let me go back just one sec. Someone asked a question. If I remove that, will there be an error? And it's going to be a compile time error. It's going to say I'm not allowed to pass this in because I'm not passing by reference. So it's looking out for you. Okay, so when we declare a function, we can also specify default values for parameters. So here I've got a function that takes a named parameter called name, and it's of type string, and it has a default value of me. And inside the function, I'm simply returning a string that is composed of the word hello, followed by whatever the value of the parameter that was passed in contains. So if I just call the function say hello to and don't pass any parameter, the parameter is going to have that default value of me. So it's going to say hello me. If I pass in a value for the parameter name, Bennett Smith, it's going to actually, do the string substitution correctly, and it's going to pass back hello Bennett Smith. So you can, use default parameters as much as you'd like. Last thing, I think, no, okay. So variadic functions. Oftentimes you're going to find that you want to pass in some values into a function, but you don't know how many values you have until you go to actually call the function. So I'm going to jump down a little bit here. So if I've got a function called compute average, and I want to pass in a variable number of parameters to it, this is the syntax for making the call. So I just say compute average, and I just start putting all these numbers separated by commas. And the way the function is actually declared, I give the parameter a name and a type, and then I give it this ... And that's telling Swift that I'm going to have multiple of this particular parameter type passed into this function. And in this case, compute average is going to return back a double. I pass in these values through this variadic function, and then I'm going to compute the average by actually calling another function. This is just to show you that I can call nested functions, and also to show you how to deal with this variadic here if you make subsequent function calls. So compute average here, the second time, it's not going to call this same function. Instead, it's calling this one up here, right? So they share the same name, but they have different declarations for their parameters. Right? The parameters on the first one is a variadic. The parameters on the second one here is just an array of integers. So I call the version that takes the array of integers. From there, I'm going to then call another function that computes the sum, which is up here, and it's going to compute the sum. Then it's going to use that to compute the average, and so on. Right? So you can kind of see what's happening as it's passing these arrays around. Let's see. So back to tuples. Here's a function that is going to return more than one type or more than one value. So this function called compute stats is going to, let me make this a little bit bigger there. Compute stats is going to take in a variadic of numbers, and it's going to return two integers and a double, right? So int double. And so it's going to compute the sum, the average, and the count, and then it's going to return them like this inside parens. Now, if I want to call that method, I can call it like this. And so now I have a variable called stats, which contains my tuple. So it contains these three values. But the only way I can refer to the individual elements in that tuple is by position. And so the language allows me to put this .0 or .1 or .2 on a value, on a tuple. And that lets us get to a specific one of the elements in the tuple. This is easy, but maybe not the most expressive, right? The person who wrote this function has to have some other way of communicating to you what each of these three values means. It would be better if they could assign names to these three values, and that's possible. And so here's an example of, actually make it a little bigger still. So here's an example of returning a tuple, but the person who authors the function gets to provide names for each of the elements in the tuple. So the first element is a count, the second element is a sum, and the third element is an average. Now when the function gets called, so here we're doing the same thing. We're saying compute stats, we're passing in some values, and now I can refer to the individual things. Instead of by .0, .1, .2, I can refer to them by their names. So named stats.count, .sum, or .average. Okay, so that's definitely a handy way to deal with that. Okay, let's go back over here. One last thing I want to show you is just a visualization tool that's part of playgrounds. So in a playground, you can change values in a loop. So here I've got a for loop that's going through and changing this value of j. And notice that it drew this graph for us over here. Okay, so this graph is the result of having run the app. And down at the bottom here, there's a timeline. And I can actually grab this slider and I can go back through time and I can see what the values were as I'm going along. So basically, I can kind of debug visually some of what's happening in this playground. That's just kind of a fun thing to show you at the end here. All right, let me do one last example for you, and then we'll wrap up. So the last example is, it's also on that GitHub repo, but there's a subdirectory here called scripts. And in scripts, I have a file, just a text file called hello.swift. And the point of this file is to show you that you can actually run Swift just as command line tools, and like you could use it as sort of a scripting language to automate things in your build process, maybe for your Xcode project. So this is an example Swift script. The thing that makes this thing run is this first line here. It's a typical sort of a bash shell invocation line that identifies the tool or the language that should be run. In this case, it's telling us that we want to run xcrun with Swift in what's called immediate mode. And then everything else that's in this file, except for the line numbers, everything else that's in this file here is Swift syntax. So I could do something like var foo int equals 10. I could do that. And now if I run this program, oops. Come on. There we go. It runs the program just fine, and away you go. So don't think you only have to play with Swift in the playground, even though that's a very convenient place to do things. You can also do things here on the command line. And if I were to have some kind of a syntax error in here, the compiler is going to do similar things to what you might be familiar with in other command line tools. It's going to show you parsing errors, for what you've done wrong. Okay, so that pretty much wraps up that stuff. Any questions? If anybody has any questions, fire away in the chat area. And if you're looking for the practice files, here is a URL that points to where you can download them from. It's on GitHub under the iOS Weekend Samples account, and it's called Swift Intro Playgrounds. And you can just clone that onto your machine and load it up in Xcode 6 and start playing around with that stuff. Okay, so if there are no questions, thank you very much. You can reach me at the email address shown on the screen there. And thanks again for attending.